Assalamualaikum warahmatullahi wabarakatuh. The purpose of doing this video is to explain about types 2 errors in probability. My name is Ainomara binti Masri and my matric number is 280555. The objective of doing this video is to review the use of statistics to estimate population parameters, review hypothesis testing to determine the significance of statistics, discuss the potential for change and chance error in estimation, identify type 2 error probabilities, associate the type of error with the calculation of power and sample size. We will looking on meaning of error. We will look into error in statistical decision making. Using hypothesis testing, you can make decisions about whether your data support or refute your research predictions. Hypothesis testing starts with the assumption of no difference between groups or no relationship between variables in the population. This is the null hypothesis. It's always paired with an alternative hypothesis, which is your research prediction of an actual difference between groups or a true relationship between variables. As we can look here in the table, there are random error, systematic error, and chance error. Random error is random and not connected to any way the methodology of the study or the way the population was sampled. This error is generally regarded as due to chance. Next is systematic error. Systematic error has a recognizable source either related to the method or the sampling. This is also often called a bias. For example, a selection bias which is systematic error that results because of how you sample your decision and population. The next one is chance error. Chance error can be further described as type 1 or type 2 error probability, based on what effect the error has on your interpretation of the statistical data. Next, let's move to the meaning of type 2 error. A type 2 error means not rejecting the null hypothesis when it's actually false. This is not quite the same as accepting the null hypothesis, because hypothesis testing can only tell you whether to reject the null hypothesis. Instead, a type 2 error means failing to conclude there was an effect when there actually was. In reality, your study may not have had enough statistical power to detect an effect on a certain size. To look more on explanation and examples of type error. As we can see on the table above, it shows that when the null hypothesis is true, it will be correct decision, and if the null hypothesis is false, it will be the type 2 error or beta. For example given, I will sample two populations and test the null hypothesis that population A has the same rate of bladder cancer than population B. Then, compare the sample and fail to reject the null hypothesis and state that the rates are not different. In reality, the rates are different, but we made a type 2 error probability because our samples were not large enough. Slides above show that a diagram of null hypothesis of type 1 and type 2 errors probability. Now, let's move on to type 2 error and power. In the previous slide, the example we have learned is that we can have the type 2 error if your sample size is not large enough. Power is the ability to detect difference if there is the inverse function of the type 2 error or beta. Power equals to 1 minus beta. A typical minimum for power is 80%, so the largest preset for beta is 0.20. As with alpha, the smaller is better as it allows less opportunity for chance error. Sample size is very important because with an underpowered study, you could fail to reject a null hypothesis that should be rejected. This slide shows formula type 2 error and sample size. You do not need to know the above formula or use it during this class to calculate your sample size. What you do need to know is that the both preset alpha and the preset beta are directly related to the sample size. As you set those lower, the Z value associated with them gets higher. And therefore, the sample size required gets larger as well. The more you want to protect against the possibility of error, the larger your sample will need to be. Next, we will focus on frequently asked questions about type 2 error. The first one is how to reduce the risk of making a type error. The risk of making a type 2 error is inversely related to the statistical power of a test. Power is the extent to which a test can correctly detect a real effect when there is one. To indirectly reduce the risk of a type 2 error, you can increase the sample size or the significance level to increase statistical power. The last one is why is it important to watch out for type 2 errors. If you fail to see effects of variation in your alternative hypothesis where there actually exists, you are be wasting your time and not taking advantage of opportunities to improve your conversion rate. I think that's all for my presentation for today. Thank you for watching.